Superheated carbon blocks can provide green industrial energy. Hi, I'm Kingdangerously. This is a time vortex from the 2120s. We're remembering the next 100 years here on Future History. We're going to talk about a company called Antora today. They're sort of a startup. They're an affiliate of Third Derivative, which itself is an affiliate of RMI, which is sort of a greeny-weeny think tank. You can look up any of those things. We'll put them in the place for the clicks. They're all working basically to advance green energy to help the world get to a sustainable future, which in the 2120s, as you may have heard me say, we have achieved. Batteries are great. Green energy pours in from all sorts of renewable sources like the sun and the waves and fusion nuclear power. But in the 2020s, it's still sort of an emerging, exciting tech. And the reason Antora is a cool company to talk about is they're doing something no one else is doing. And what they're doing is they're filling like a shipping container size block with a bunch of carbon graphite chunks, basically just blocks of graphite. And they chose this material because it's widely used. It's the product of a mature industrialized chains. I believe they put it on their 2022 website, and basically that means it's all over the world. There are tens of millions of graphite blocks are used in all sorts of industrial applications like making aluminum and steel all over the world. So they're easy to source, they're relatively cheap, they're relatively common, critical because Antora is hoping to scale this technology. And what they do is they run electricity through them, could be from any source, but the way they like to do it is they take excess power from solar or wind facilities that aren't being used at the time, and they pump that into the graphite blocks, which then get very, very hot indeed, like really, really hot, like thousands of degrees hot. And then when they are ready to deploy that energy, they open shutters and beam that heat directly at the surface that they're going to affect. And they can do lots of industrial stuff with this, which is really exciting. They can also, however, convert it to electricity using a special solar panel converter. And you might be asking, why would you take the green energy, heat up this block, and then turn it back into green energy? And one of the reasons is just sort of convenience of density, because it would take 5 to 10 acres to get a megawatt of solar power from panels, but you can condense that down into this shipping container sized row of, they call it sort of a toaster style grid of graphite blocks that are superheated. So you can have that much energy in this much smaller footprint, and then you can turn it back into electricity at this location if you want, or you can use it to do exciting laser wazer thing like blasty wasties. Maybe I'll stop doing the repeat why. They can, for example, melt steel with this. They can weld metal and glass. They can help produce fertilizer. And the critical number here to think about is that in the United States, 30% of greenhouse gas emissions are the product of industrial processes. Heavy industry produces 30% of the United States' greenhouse gas emissions. So that's a large percentage. I don't have to tell you, it's almost a third. And what's really tricky about this is it's very difficult with other technologies to get the kind of raw power, like brute force that you need to melt metal or create fertilizer, or in some cases do some things relating to the concrete supply chain. So you have to get the grid completely green, you have to have a solution like Antora's providing here with this highly powered laser beam effect. It's not exactly a laser, it's more like a gushing heat wave, but it's laser-esque in its intensity. So what else can I tell you about this? Where does it go, you might ask, 100 years from now? Is this energy storage and delivery method still popular? Not really. In the 2100s, we actually have like incredibly sort of magic seeming to the 2020s style batteries that can store this much energy, but at much lower temperatures. So you can do it at basically room temp. But this is the right direction, we think, humbly, from the future. Heating these graphite, quite common carbon materials, which again, you may have bell rung yourself, is the stuff that's in the air that we're trying to get out in the first place. So you could pull carbon down, recapture it, build things like these graphite blocks. and use them as part of the energy chain to, say, pull more down. You could, if you wanted to, do that with carbon removal. You'd use the carbon to power more carbon removal. But so this is an important step toward what will eventually be sort of more elaborate versions of the containment system that Antora uses. So they, prevent fires by locking it all up in a box. And in the future, that stuff will get integrated. The containment will be integrated into the material itself, such that you're storing the heat in a non-dangerous way, to the point that you could have that much energy in an object you could touch, and then you could open it up and shoot laser beams around, which, as you can imagine, is quite dangerous, and we don't encourage that sort of behavior. If you're curious, the graphite blocks get heated to about 2000 degrees Celsius, which is like 3600 degrees Fahrenheit, and they can apply most of that temperature to the objects that they manipulate. So they could take the 2000 degrees, you open it through the shutter, and they shoot out like 1500 degrees onto the metal, which then, melts. And in Fahrenheit, they're shooting out about 2700 degrees. So this is really exciting. It's something you can look into. It's something you could invest in if you're an industrial investor. And if you're an engineer, it might be just like cool to learn about. Maybe reach out to the company or reach out to their sister parent affiliates, Third Derivative and RMI. Okay, I hope you're getting hot and bothered by this hot new technology. I sure am. Let's melt the future. Okay, bye.